Hello! Okay, we are going to start chemistry. This is awesome. I'm so excited. Can you take out booklet number 1? And you should also have your periodic table. So the one that you have is double-sided. It has this periodic table, and then it has the ion chart on the other side. And that's great. We will come to use that in a little bit. But right now, we just need these two things for now. Okay? So let's open it up. Page number 1. Okay? So this first booklet is all a review of what you did in grade 9, just to get you comfortable and thinking about chemistry again and all the different parts and stuff that we should be doing. Okay? So first up, all matter is made up of what? Atoms. Right on. Okay? Okay, and atoms are made up of protons. Okay, that's P with a little positive sign. Electrons. Okay, which is E with a little negative sign, and neutrons. Okay, and that's the N with a little 0 or null set. Okay, so protons and neutrons are found in the nucleus, and electrons orbit around the nucleus. And in a neutral atom, which is what you would have been looking at in grade 9, the number of protons and electrons are equal. Awesome. Oh, sorry. So far, so good. Okay. Hope this is sounding somewhat familiar. Okay, turn the page. Okay, so now in grade 10, there are 2 models that we're going to look at. So in grade 9, we did Bohr models, and we still want to know those, but we're also going to talk about Lewis dot diagrams as well. Okay, so in Bohr models, right, this model depicts electrons in an atom orbiting in specific energy levels or shells or orbits, lots of different words that we could call them, okay? The inner shells have lower energy levels, so the ones that are closest to the nucleus have the lower energy levels and are filled first, okay? So the first level holds up to 2 electrons, the second level holds up to 8 electrons, the third level holds up to 8 electrons, and the fourth level holds up to 18 electrons, okay? So that's the Bohr model, okay? And we're gonna practice some examples in just a second. Let's talk briefly about what the Lewis dot diagram is about, okay? So in the Lewis dot diagram, this model uses the symbol of an element to represent the kernel, like popcorn kernel, of the atom. And the kernel includes the nucleus, okay, and all the inner electron shells. Okay, everything except for the very outer shell, okay? And it uses dots to represent the valence electrons. Do you remember what valence electrons are? Haha, the outermost electrons. Okay, right on. Now, Lewis dot diagrams are more popular than Bohr diagrams in chemistry because they are less time consuming and because valence electrons are the single most important factor in determining an atom's properties. Okay, so I'm just going to get like another color here. Is that even going to work? Let's see here. Okay, and I'm going to star this. I'm going to put stars around this. This is super important. Okay, the number of valence electrons for each element determines its properties and who it's going to bond with, and that is what we're learning about in grade 10 is bonding. Okay, turn the page. So let's compare what the Bohr diagrams and the Lewis dot diagrams look like, okay? So now we want to take out our periodic table, okay? And we're going to look for lithium, okay? So lithium has a symbol Li. Ah, there we go, okay? So if I take a look, is it going to let me zoom in here? Okay. So lithium has, so up here is the atomic number, always in the top left-hand corner on the periodic table, and on the bottom is the atomic mass. And then here we have the symbol, the name, and then what state, if it's solid, liquid, or gas at room temperature, okay? Okay, so you can kind of see a little shaded circle here. Let's make that our nucleus. Okay, and inside our nucleus, we're going to write how many neutrons and protons we have. Okay, so I'm going to go P equals and then N equals. Okay, so here we know that the number of protons, remember, is the same as the number as the atomic number. Okay, and maybe I'm just going to write that on my periodic table. So atomic number equals number of protons equals number of electrons. Okay, you should add that too, okay? So if I'm doing that and I look at my atomic number, it's 3, so that means I'm going to have 3 protons. Okay, and if I have 3 protons, and I also have 3 electrons, okay? So I'm going to add my 3 electrons, okay? So the first shell can only hold 2, so I'm going to put my 1 here and then my other one in the bottom. If you're like, Miss Labiuk, does it matter? Yes, it matters. It matters where they go, and you'll see them in different ways. But for the SRSS, as a group, we have chosen to all do it this way so that when we're bonding, it doesn't matter which class we do, it's very easy to follow. Okay, so 1 at the top, 1 at the bottom. And then we have 3, so we put the next one in the next shell. Okay, so there's our Bohr diagram. Okay, and if we go to our Lewis dot diagram, the Li represents our nucleus and all of our inner shells. So all we have to do is draw 1 dot. Hey-o, that's it. Okay. Let's take a look at the next one, okay? The next one is oxygen. So find oxygen on your periodic table. And I am just going to go up here and show this as a nucleus, so we're not. Oh, hold on, forgot the neutrons. How many neutrons do we have? Okay, well, if you remember from last year, our atomic weight is our weight minus the atomic number is going to tell us how many neutrons we have. So this minus the atomic number equals number of neutrons. Right on, okay? So in this case, we have 12, and we'll just round to the nearest whole number. So 12.0, so 12 minus 6 is, oh, sorry, lithium. Ha, here we go. 7 minus 3, 4. Okay, so lithium has 4 neutrons. Okay, right on. Oxygen. Okay, oxygen's atomic number is 8, and its mass is 16. Okay, so if I look here, I'm going to write P equals and N equals. So how many protons will oxygen have? Hold on, it'll have 8. How many electrons will oxygen have? It'll also have 8. Okay, so I start 1, 2, 3, and now I'm going to go clockwise 90 degrees. 3, 4, 5, 6, and now I'm going to go back up 7 and then 8. Okay, so we start at 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock, 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock until we've added all the electrons we need. Okay, and how many neutrons does it have? Okay, well, if I look here, 16 minus 8 is 8. Okay, so I'm going to have also 8 neutrons. So I'll just make that a little bit easier to see. And how many valence electrons does oxygen have? Well, I look at my outermost shell here of oxygen and I have 6 valence electrons, okay? So I can just copy the same arrangement that I have there. There we go. And there's oxygen, our Bohr diagram and also our Lewis dot diagram. Okay, last one is aluminum. Okay, so take a look here. Let's find aluminum on our periodic table. Ah, there we go. Okay, aluminum, number 13. Okay, and we'll call that 27. Okay, so mass of 27 and atomic number is 13. Okay, so we have protons equals, neutrons equals. Okay, so our atomic number was 13, so we're going to have 13 protons and 13 electrons. Okay, so I start 1, 2, first shell is full. Next one, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I still have 3 more, 10, 11, 12, 13. Okay, so now I filled in all of the electrons in their proper shells. Okay, now if I take a look here to draw the Lewis dot diagram, I just want to look at this outer ring, and how many are there? Well, there's just 3. 1, 2, 3. Right on. Okay, so I can't reiterate this enough. Our valence electrons, so these ones in the outer edge, are the single most important factor in determining an atom's properties. Okay, so next thing I want you to try is to make a Lewis dot diagram for the first 20 atoms on the periodic table. And we've already done some of them, right? We already know that lithium is 1. We know that oxygen is 6. So 1, 2, 3, 4, 5, 6. And we know that aluminum is 3. 1, 2, 3. Okay, so remember, whenever we are putting our valence electrons around an atom, so let's just call something Z, right? We want to put our first one here, then our second one here, then our third one, then our fourth, then we'll come back up and do 5th, 6th, 7th, 8th. Okay, and same thing when we do Bohr diagrams. Okay, so I'd like you to pause and try it out, and then you can come back and check my work to see. Oh, actually, you know what? Pause, try it out, and then does your work look like this? Okay, so what do we notice here? Notice how everything in the first column has the same number of valence electrons. Notice how everything in the second column has the same number of valence electrons. Same thing in the third, the fourth, and the fifth, and the sixth, and the seventh. And the only difference is that in the eighth, they have, their outermost shell is full. So helium only has 1 shell and it's full. Neon only has 1 shell and it's full. Argon only has 1 shell and it is full. Okay. The other thing I want you to try is Bohr diagrams. Okay. So we're only worried about the first 20 elements in grade 9 and grade 10. And we've already done some of these already, right? We did oxygen, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, okay? And we did lithium, 1, 2, 3, okay? And then we also did, what was the other one that we did? My mind just drew a blank. And we also did aluminum. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And if you're looking at this and going, Miss Labiuk, I can't write neutrons and protons inside there. So if you can't, no problem. Just draw a little arrow to the middle and then go neutrons equals protons equals. Okay, protons equals 8, and here neutrons also equal 8. Okay, if you can write small and get it inside there, that's awesome. Okay, so here our neutrons equaled 13, and our neutrons were, why have I just lost that? Our neutrons were 14, and our protons are 13. Okay, and here for lithium, okay, we have our neutrons were 4 and our protons were 3. It doesn't matter which one you have first, neutrons or protons or neutrons, it's totally fine. But I'd like you to try those 2 sheets yourself. And once you see the pattern, it'll go really quickly. Okay, awesome, off you go.